Hello everyone, welcome to our page. Today we will discuss about some previous year Csir-ugc net questions of linear algebra. We have already read about some basic concepts of linear algebra in the previous 3 lectures. Now it will be not difficult if you read all those lectures to solve these questions. Now question number 1, which was from June 2019 CSIR NET. Question number 1 is, consider the vector space Pn of real polynomials in X of degree less than or equal to n. So that Pn is the real polynomials, is the vector space of real polynomials whose degree is less than or equal to n. Now there is a define a T linear transformation from P2 to P3, that is the degree of whose degree is P2, degree of P2 is less than or equal to 2 and degree of P3 is less than or equal to 3 by T of f of x. Tf of x is equal to integration 0 to x ft dt plus f dash x. Then the question is, what will be the matrix representation of T with respect to the basis 1x x square, that is the standard basis of P2, and the standard basis of P3, that is 1x x square x cube, is which is the following. From these matrices, what will be the matrix representation? Now to get the matrix representation of that linear transformation, we have first compute what will be the image of that basis with that linear transformation, that is 1x and x square. So we have to compute T of 1. So T of 1 will be, as the definition of the linear transformation is 0 to x f of integration 0 to x ft dt plus f dash x. So T of 1 will be integration 0 to x 1 dt plus 0. Since fx is equal to 1, in that case fx is equal to 1, so f dash x equal to 0. So the integration will be t from 0 to x, that is x. Now what will be the T of x? T of x, in that case f of x equal to x, so integration of 0 to x t dt, and in that case f dash x will be 1. So after the integration it will be x square by 2 plus 1, and T of x square, here that f of x equal to x square, so T of x square equal to integration 0 to x t square dt plus 2x, that will be x cube by 3 plus 2x. Now we have to define this t1, tx and tx square by the basis of P3, that is 1x x square x cube. So we have got that t1 equal to x. So we can define it as 0 into 1 plus 1 into x plus 0 into x square plus 0 into x cube. Since 1x x square x cube is the basis of the P3, and in that case the coefficients are 0, 1, 0, 0. In the same things happens in the next is T of x, that is x square by 2 plus 1. It can be defined as 1 into 1 plus 0 into x plus half into x square plus 0 into x cube. So the coefficients are 1, 0, half and 0. Same as T of x square, that will be 0 into 1 plus 2 into x plus 0 into x square plus 1/3 x cube. So what will be the matrix representation of T? In that case, we have to compute that this is the coefficient 0, 1, 0, 0 that will be in column matrix. So first column will be 0, 1, 0, 0. Second column will be 1, 0, half, 0. So 1, 0, half, 0. And the third column will be 0, 2, 0, 1/3. So 0, 2, 0, 1/3. And this is that option number 2. So the answer is option number 2. Hope that you will all understand the problem. This type of problem is very easy, I think, if you know the how to convert linear transformation in a metric representation. That's the second lecture of my channel. You can get that about it. Now go for that second question, which is also from June 2019. Let P of x denote the characteristic polynomial of a matrix A. So if A is a matrix, then P of x denote the characteristic polynomial of that matrix. Then for which of the following matrices P of x minus P of A inverse x is a constant? Now these are the following matrix. That 4 following matrices are there, every one of order 2 cross 2. Now test for the first one. The matrix A is 3, 3, 2, 4. So the determinant A is equal to 12 minus 6, that is 6. So what will be the inverse of A? That is A inverse. We know that A inverse is 1 by the determinant, that is 1 by 6, and adjoint of all the elements. So the adjoint of 3 is 4, adjoint of 3 is 2, that is minus 2, and we have to transpose it. So here will be the minus 2, and what will be the element of 2? Adjoint of 2 is minus 3, and in the transpose it will be here that minus 3, and the adjoint of 4 is 3, so here is the 3. So this is the A inverse. Then compute that characteristic polynomial of A, that is P of PAX. It will be, according to the definition, it will be determinant of xi minus A. So determinant of x minus 3 minus 3 minus 2 x minus 4. So we have got that x square minus 7x plus 6. Now what will be the P of A inverse x? That is the characteristic polynomial of A inverse. That will be determinant of xi minus A inverse, and we have got that 1 by 36. Since the determinant is 6, the determinant of matrix A is 6, so we will have got 1 by 36, and we have got that characteristic polynomial will be 1 by 36 into x square minus 7x plus 6. Now clearly P of Ax minus P of A inverse x not equal to constant, because here the coefficient of x square is 1 by 36 and coefficient of x is minus 7 by 36, and coefficient of P of x, in that case of P of x, coefficient of x square is 1 and coefficient of x is minus 7. So the both are different. So P of x minus P of A inverse x not constant, it contains the value of x. Now let's check that the variable x will depend on that in this two element, that is 3 and 4, that diagonal element. In that case it will also be x will also depend on that element, that 4 and 3. In that case 3 and 3, let's get 2 and 4, and for every A and A inverse the diagonal element will be the same, because these are the 2 plus 2 matrix, here 3 and 4, and A inverse also 4 and 3, here also 4 3, so the 3 and 4 will be the same in the inverse of A, and rest are as follows. So in which case this equation will be a constant. We can do it as we have done in the option 1 for 2, 3 and 4, but it will be lengthy. Now in option 1, P of Ax minus P of A inverse x is not constant since the determinant of A is 6. So we have get that P of A inverse x, we have get that 1 by 36 into that determinant. So if it was 1, then the coefficients of x square and x will be the same of P of x. So in that case it will be constant, but we get that 1 by 36 as determinant of A was 6. So in which matrices the determinant will be 1, then P of x minus P of A inverse x will be a constant. So we have to just check in which matrices the determinant is 1. So let's check it. The matrices of option number 2 was 4 2 3 3, so the determinant is 6. So option 2 is also wrong, but in option number 3 the matrices was 3 2 4 3, so the determinant is 9 minus 8, that is 1. So in that case the x will vanish and that P of Ax and minus P of A inverse x will be constant. So option number 3 is the right answer. And option number 4, determinant of A is minus 1. So it will not be the right answer, so it is wrong, because in that case the coefficient will be the same, but there will be a minus sign, so it will not be right. That's all for today. We'll discuss about something else in our next lecture. Thank you.